Hi, welcome to a lesson on parallel and perpendicular lines. So we've been graphing all these lines in different forms, and now we're going to talk about some special properties that exist with different lines. So, first we're going to discuss parallel lines. So, the first thing we need to know about parallel lines is that they never touch. Ever. Ever. They never touch. The reason they don't do that is because they have the same slope. So we have this graph here, and let's just take a quick look and see why. Now, please note that I don't have a pretty graph here, so it may look a little off, but I promise if you were to do it on a nice graph, you had the same slope, it would work. So let's just take the point 1, 1, and let's go up. Let's have a slope of 1 over 2. So we go up 1, right 2. Let's put a dot at 0, 2. If we do the same thing, if we go up 1, right 2, we see we're here. You see how they're basically, it looks like they're just about the same area. If I were to draw a line through here, you'd see 2, that. Go up here to 0, 4, up 1, right 2. You see that they pretty much look like they are never going to touch, despite my beautiful drawing. So, parallel lines, they never touch, they have the same slope. And that same slope is important when we're talking about writing parallel lines. Now, writing parallel lines is pretty easy. So, what I'm asking right here is, where we have y equals 1/2 x plus 4, I want a line that is parallel to y equals 1/2 x plus 4. Now, in order for it to be parallel, it only needs to satisfy that one property that the slope is the same. So we look, what's the slope here? Our slope is 1/2. So, all we need to know here is that y equals 1/2 x. And then our intercept, our b, since this is in slope-intercept form, can be anything we want. It can be 0 like it is now. It can be -2. It can be +3. As long as it's not that +4, so it's the same line, this line is parallel. We look down here at the next one where it's in point-slope form. We have y minus 5 equals 2 over 3 times x plus 1. We know from our point-slope form that this tells us a point on a line, and this is our slope. And that's what we need to know. We need to know that our slope is 2 over 3. And that's pretty much it. We get to have fun and be a little creative the rest of it. Sorry. So I just need another point on my line that's not that. Going to have a y as 5. So let's just do -3 equals 2 over 3 x, and something that's not +1 minus -5. Let's put a -5 here. And this line is parallel to the line above it. So, now we have these 2 points, 2, 4 and 4, 3. And again, since we just want a line that's parallel to whatever line this is, we just need to know the slope. And everything else is pretty easy after that. So let's find the slope using our slope formula. So 3 minus 4 over 4 minus 2. We get -1 over 2. So we know our slope is -1 over 2. Now, whenever you're writing your line that's parallel, you can pick any form you want. It doesn't matter. Generally, I'd stick with the slope-intercept form or the point-slope form, because standard form would get a little tricky because you'd have to do some manipulation. So try to stick with slope-intercept form or point-slope form. It does not matter which one you choose. So I'm just going to do slope-intercept. So y equals -1/2, and my intercept is going to be +3. That works. So here I have two examples for you to do. I want you to find out two lines that are parallel to these using methods we did before. So go ahead and pause the video and work those examples out now. And here are my answers to this. You will note that on my answers, when I put it in slope-intercept form, I didn't actually put a number because, well, you have freedom there. Your answers aren't going to match exactly mine for all these because it can be +4, +3, +2 whenever you're putting in slope-intercept form, or if you put it in point-slope form, the point on the line could be different. So as long as you got that slope right, that is all we're concerned with. So enough about parallel, let's talk about perpendicular lines. Perpendicular lines create a 90-degree angle, and their slopes are opposite reciprocal. Here's what that means. So if we see that the slope is 1/2, the opposite of 1/2 is -1/2. The reciprocal means that we flip the fraction. So what we're going to do is we're going to flip this, and it becomes -2/1, or just -2. So whenever you're looking at the slopes of perpendicular lines, whatever it is, you're going to flip it and change the sign. Now here on this graph, there's actually perpendicular lines already. Right here, our x-axis and our y-axis, they make that right angle. So this is what your lines will look like after you graph them. They'll look like that right angle that you see whenever you have the x-axis and the y-axis meet. So let's write some lines. And again, just like with parallel lines, we're mainly focused on the slope. Your intercepts could be different, the point on the line could be different, but the slope is the key. So here our slope is 3/4. Well, I want the opposite reciprocal. So I'm going to flip the fraction, 4/3, and it's positive, so I'm going to make it negative. So y equals -4/3 x, and let's just say -1. That is going to be perpendicular to y equals 3/4x plus 2. We look at our point slope form. Y plus 3 equals 4 multiplied by x minus 2. Our slope is 4. We're going to look at the opposite reciprocal. So we're going to flip it. So it's 1/4, and it's positive there, so we make it negative again. So y minus 2 equals that important slope, x minus 3. So this is perpendicular to that. And finally, we have 2 points. Just like before, we're going to find the slope. Then we're going to do the opposite reciprocal, and then we're going to put it in whatever form we want. So -3 minus 5/1 minus 2. So we get -8 over -1. So that's 8. So I want the opposite reciprocal of 8. So the reciprocal is 1/8. Opposite is negative. So we get y equals -1/8 x and plus 7. Why not? So last thing we're going to do is, you have these 2 examples for you to try on your own. I want you to find the perpendicular lines to these 2. So go ahead and pause the video and work on that now. Alright, here are the solutions, and once again, the key factor here is the slope, so I left off the intercept. It can be whatever number you want it to be. The key is our slope. So go ahead and check your work here, and after you do that, you're done with this video.